Hello, and a very warm welcome to Cognito Key. Today, we're diving into a really cool device that lets us peek into the unseen world. So, let's get right to it. What is a bolometer?
Okay, so imagine trying to measure something you literally can't see or touch or hear. I'm talking about stuff like microwave energy, or radio frequency radiation. It's all around us, but how on earth do we actually know how much of it is there? Well, that's the big question we're tackling in this explainer.
So yeah, that's the core problem, isn't it? You can't see the energy coming from your microwave oven or a cell tower, so how can you possibly measure its power? It sounds kind of impossible, right? But scientists and engineers came up with an incredibly clever solution. And that solution, the hero of our story today, is the bolometer. This brilliant little instrument was designed to do exactly that, to measure the power of invisible radiation simply by detecting its heat. So, what is it officially? Well, a bolometer is a device that's all about detecting and measuring the heat that comes from electromagnetic radiation, especially in that microwave or radio frequency range. The key thing to remember is it doesn't see the microwaves, it feels their warmth.
Right, so how does it actually do that? The real magic happens inside something called a bridge circuit. Now, I know that might sound a little technical, but the idea behind it is actually super simple and pretty elegant. Let's break it down.
The best way to get your head around the bridge circuit is to just picture a perfectly balanced seesaw at the park. When everything is equal on both sides, it just stays perfectly level. That balanced state is our starting point. The circuit is stable, nothing's really happening yet.
Okay, here's how it all comes together. First, a special little sensor inside the circuit soaks up that invisible microwave energy. This is like putting a tiny little weight on one side of our seesaw. As that sensor absorbs the energy, it heats up, which then causes its electrical resistance to change, and that change in resistance is what knocks our seesaw, the bridge circuit, off balance. The circuit then measures exactly how much power it needs to get that seesaw level again, and that measurement tells us precisely how powerful the microwave field was. Pretty neat, huh?
So really, the most important point here is this. The whole entire process depends on that change in resistance. It's the physical clue that tells us about the presence and the power of that invisible energy. The bridge circuit is just the super-sensitive scale that can measure this tiny, tiny change.
Now, that special sensor we were talking about, well, it's not always the same. There are actually two main types that are used in bolometers, and get this, they behave in completely opposite ways. They're called the Barretter and the Thermistor.
So on one side, you've got the Barretter. This is a very fine, delicate little metallic wire. When it gets hotter, its resistance goes up. We call that a positive temperature coefficient. But then on the other side, you have the Thermistor, which is made from a semiconductor material. When a thermistor gets hotter, its resistance actually goes down. That's a negative temperature coefficient. Basically, you can think of it like this. Barretters are a bit more fragile, while thermistors are generally way more durable.
Okay, so we know how they work, but so what? Why is this all so important? Why does any of this matter? Well, it all comes down to one thing: the need for incredibly precise measurements in science and technology.
And the bolometer is unbelievably sensitive. It's typically used to measure really, really low power levels, usually somewhere in the range of 0.01 to 10 milliwatts. I mean, that is a tiny amount of energy, and being able to measure it with such accuracy is absolutely crucial for everything from developing telecommunications gear to building instruments for astronomy.
All right, so let's do a quick recap of the key ideas. First, a bolometer is a super smart device that measures invisible energy by turning it into heat. Second, it does this using a sensitive bridge circuit that's looking for a change in electrical resistance. And finally, the whole thing works because of two types of sensors, the Barretter and the Thermistor, which react to heat in opposite ways.
And that kind of brings us to a final thought. We've just seen how a pretty simple principle can be used to measure an invisible force like microwave radiation. It really makes you wonder, doesn't it? What other unseen energies and forces are out there all around us, shaping our world in ways we're only just starting to figure out?
If you enjoyed this little journey into the invisible world, please don't forget to hit that like button, share it with someone who's curious, and of course, subscribe to Cognito Key for more insights that unlock the secrets of science and technology. Thank you so much for watching.